Okay, with here we want to look at quadratic equations. Now, a quadratic equation is an equation whose highest term is 2. So you'll always see the leading term raised to the second power. Okay. So even though all these equations take on different looks, they're all raised to the second power, as we can see. And we could just look at different ways to check them out. So our first option, anytime we want to solve a quadratic equation, we always want to look to factor, right? So here we have a difference of squares. So we just want to solve this algebraically, right? So in this equation, we want to add 36 to both sides. So that's x squared is equal to 36. And now we want to take the square root of both sides. All right, we want to take the square root of x squared and the square root of 36. Remember, that's how we get rid of our squared term. You simply take the square root of both sides. The square root of x squared gives us x, and the square root of 36 gives us plus and minus 6. Remember, you need two terms. You can't just have 6, and you can't just have negative 6. It's going to be plus or minus 6. Okay, let's look at this next term. Here we have x squared minus 3x minus 40. So here I know I need two numbers whose product can give us a negative 40, but whose sum can give us a negative 3. I'm going to say it again. They have to multiply to give you a negative 40, but you add them up to give you a negative 3. So the first thing, and this is why your multiplication tables are so important, you have to think up all the terms that can give you a 40, like 20 and 2. That wouldn't work. Or 10 and 4. That wouldn't work. What about 8 and 5? That works because the difference between 8 and 5 is 3. Now, this is what we need to do from here. The middle term is negative. So we know that the negative has to go with the larger number. What number is larger between 8 and 5? The 8. So that's how we know where to put our positives and our negatives, right? So our answer in this case is going to be x minus 8 and x plus 5, but we're not finished. All right. Now, x minus 8 is equal to 0. So we move the negative 8 to the other side, and we just make that x is equal to 8. X plus 5 is equal to 0. We move the plus 5 to the other side. Or since we see addition, we subtract it, and that answer is going to be x is equal to negative 5. So our final answers are x is equal to 8 and x is equal to negative 5. You could easily put both of those terms back in our equation and make sure they equal 0 to check them. So now let's look at this next one. We have x squared plus 11x plus 30 equals 0. So now we need two terms that can multiply to give you a positive 30 that add up to give you and 11. Okay, so once again, I go and think about all the things that add up to give us 30. Um, 30 and 1, that wouldn't work because your sum would be 31. 10 times 3, that wouldn't work because your sum would be 13. But what about 6 and 5? And that's how we choose this. That's x plus 6 and x plus 5. How do we know it's plus? Because both of them have to be positive. All right, so we're not finished here. Remember, we're going to say x plus 6 is equal to 0, and also x plus 5 is equal to 0. When we move that positive 6 to the other side of the equation, it becomes negative 6. And when we move this positive 5 to the other side of the equation, it becomes negative 5. So those are our final answers. Now, let's look down. These problems take on a slightly different form, but we have to know they're still quadratic because we see this squared term. So that's the main thing that we're looking for. So now let's see how we want to solve this. Now remember, if we see a subtraction, we need to add. If we see addition, we need to subtract, right? So once we add, when we see this minus 4, we need to add it to both sides. So now 32 plus 4 is going to give us 36. I'm going to say this again. That was a negative 4. When we moved it to the other side and added it to the other side of the equation, that was going to give us a positive 4. 32 plus 4 gave us 36. Now, I want to drop it because I'm running out of space a little bit. What we need to do right here is what we did earlier and just some of our general mathematics rule. We need to, anytime we see something being squared, we need to take the square root of both sides. I'm going to draw this right here. The square root of x plus 5 squared and the square root of 36. So now this leaves us with x minus 5 is equal to 6. And also x minus 5 is equal to negative 6. Yeah, we can remember that was going to be, as we said before, the square root of 36 was plus or minus 6. So that's x minus 5 is equal to 6, and x minus 5 is also equal to negative 6. So once we finish this problem, once we add 5 to both sides, 6 plus 5 is going to be 11. And here, negative 6 plus 5 is going to be negative 1. So that's our final answer in this case. So we have to remember just to stay disciplined and continue using our rules. Now in this last problem, we want to check out, we have x plus 7 squared plus 5 is equal to 25. The first thing that should stand out is the plus 5. So what do we need to do with this plus 5? We need to subtract it from both sides. So we're going to have x plus 7 squared is equal to 20. I have to write it a little smaller to make sure I have room. And now when we have x plus 7 squared is equal to 20, As we said before, anytime you see something squared, we need to take the square root. We have x plus 7 squared is equal to 20, and we're going to take the square root of both sides, and that's how we get rid of our square, of our exponent, I'm sorry. So now we have x plus 7 is equal to the square root of 20. And matter of fact, y'all want to put the plus and the minus square root of 20. Now, this is what I want us to do. Yeah, I'm coming out to my scratch paper. I'm coming out to my scratch paper. Let's say this right here. How do we break down a 20? We could use, with this 20, we could use 4 times 5. And from the 4, that's going to turn to 2 square root of 5. Let me say this again. We break down the square root of 20. It's going to be the square root of 4 times the square root of 5. The square root of 4 breaks down to 2. And the square root of 5 stays the same. So now we have x. Remember that we need to move this positive 7 to the other side of the equation. And we end up having negative 7 plus or minus 2 times the square root of 5. So these are just different types of quadratic equations. We have other ones as well that we will look at later. These are different types, a couple of different types and different methods that we can use to help solve them.